Hi everyone, and welcome to our video on the unit circle. So the unit circle is one of the most important things for trigonometry class. This is the unit circle from just Googling. So I Googled unit circle PDF and this was one of them. So there'll be like millions of them because it's, again, such an important thing for trigonometry. It has some information on here that we currently will be getting to, but to break down what is most important about this is our t-values. So these ones that I'm underlining in green, these are the specific t-values. So t equals pi 6, here's t equals 0. Now I'm going to erase this part right here in a second. So that length is the pi 6th that we would have done in similar problems from the previous video. And let me erase again. So it gets messy if we show all of those. That's why we're not going to do all of them. I'm just going to, again, kind of erase this length right here to there. That would be t equals pi quarters. Okay, so they're just marking where it ends so that it doesn't get too messy with those arrows. So let me erase that. There we go. Okay, so but let me underline each of these parts here. So all of these in the underlined green are the t-values. And it goes for all quadrants. It goes around. Again, we're kind of zoomed in. Let's just kind of do those to save a little time on the video. But that's all of the current t-values. And then I'm going to underline in the black ink, these are the terminal points. Okay, so these are some key important terminal points for us throughout the unit circle. So it has their respective t-value and then their terminal points. And then again, just to kind of not underline everything, let's just do the first top half of that circle. Now, what we want to really do is get a pattern out of this. Usually, all we really need is the first quadrant. So in these problems right here that we're about to do, I'm going to sketch out that first quadrant right now. So number 3 will take a little bit of a hit on the room, but I think it's best if we mark these up. So I'm putting those key points here on the first quadrant. Let me keep my colors consistent. So I'm going to do this is t is 0. This is t is pi 6th. This is where t equals pi quarters is. Here's t equals pi thirds. And then here's t equals pi halves. And then their corresponding terminal points are 1, 0, square root of 3 over 2 and 1/2. They might also say radical 3 over 2. So square root of 3 over 2 or radical 3 over 2 are the same thing. And then our next terminal point is square root of 2 over 2 and square root of 2 over 2. Our next one is 1/2 and square root of 3 over 2. And then this last one in the first quadrant is 0 and 1. Okay, so the reason that we kind of want to just focus on this, so we can always go about and just memorize this whole thing. So that's often a strategy that students like. So if you want to do that too. I mean, I would say get this regardless, print this out, get it well known. However, we might not want to use our memory the whole time. We might want to try to figure out all of these values based on patterns. And again, I can't stress this enough. This is super important for our trigonometry, the whole course. So like these values with pi over 6 or pi thirds involved, I'm just going to scroll through the whole kind of unit notes that we have. So you'll start to see them with the actual trig functions. There they are again. So they're going to be through this whole thing over and over and over again. Here's a bunch in a table. Let me scroll real far down. Okay, so here's much further down, still, there they are. Okay, so those pi quarters, pi 6th, here they are again. Okay, so you see them all the way through. Let's go to the very last page, and there it is again. Okay, so they're always kind of around. Okay, so beginning from here on, we're going to see them throughout the whole course. So if you know this unit circle well, you'll have good success in this class. If you don't, then it's really bad news. Okay, so that's something we want to work on. And now it's not something that we want to or something that you might get immediately. It'll take a little time, but we do definitely want to know this well. All right, so anyway, so we have this first quadrant to help us out. Now, before I move on to doing some of these problems here, let's show at least one pattern with some of these values. Okay, so let's notice, I'm going to do this highlighted, so it's going to get a little messy. I'm going to highlight the ones with 6 in them, 6 in a denominator. Okay, so there's 6, so that we can see them all. There's all the ones that have 6 in the denominator with them. Notice that their terminal point always starts with square root of 3 over 2 and then 1/2, and then we just have to make sure the signs are correct based on the quadrant that we're in. So that's why if we know the first quadrant, if we know there's a 6 in the denominator with our pi, we know it's something like this point. We just have to figure out the signs. Now, another thing that can kind of help us along the way. So pi 6 is always in the first quadrant. Notice that all of the numerators in the first quadrant for our t values are just pi. So there's not another number with them. And then afterwards, in the other quadrants, they start to have other numbers besides just pi. Well, this highlighted one on the top left in the second quadrant is 5 pi over 6th. Now pi is about 3.14, and we can estimate these if we really want to. However, what's really important to know the placement of these is, again, notice all the 6s are all kind of making a rectangle with each other. They're also closest to the x-axis on our grid. However, to know where they are based on the quadrant, all I do is compare the fraction. So 5 over 6, that's a little smaller than 1. So 1 pi is all the way on the left. That's the just pi. 1 pi is pi. So I know 5/6 is just short of pi. Okay, so going counterclockwise around the unit circle, I know it's going to be just short of it. Whereas like 7/6, 7 over 6 is a little bigger than 1, so bigger than 1 pi, so it goes a little bit past it. Okay, so we're just trying to figure out where these go real quick. And then the other one that's highlighted in yellow, 11 pi over 6. Well, again, 11 over 6 is really close to 12 over 6. 12 over 6 is 2. 2 pi is where the unit circle ends after one full rotation. Okay, so we're just trying to get this pattern. Again, trying not maybe to memorize the whole thing, but to get a pattern to help us move along for the whole semester. All right, the other thing that's on this unit circle are the degree measures. So we'll see those soon. All right, so but our focus right now are the ones with the pi's in them. So those are radian measures. Okay, let me do one other highlighter. So in the pink, so again, all the ones that have 3 in the denominator, all the ones that have 3 in the denominator are closest to the y-axis every time. So they're always closest to the y-axis. And then their terminal point always again looks the same. It always looks like 1/2 and then radical 3 over 2. Notice the switch of those numbers compared to our yellow highlight. But after that, all we have to do is figure out the signs. Okay, so quadrant 2, the x-coordinate is negative, the y-coordinate is positive. And then like down here, quadrant 3, they were both negative. Quadrant 4, x is positive, y is negative. Okay, so that's how we can look at these. Okay, so and there's other tricks along the way that will help us. I think for now this is going to be good. Let's break down these 3 problems here. Okay, so this is find the terminal point determined by t. Now on all of these problems, I'm always going to sketch out a little mini unit circle. So I'm not going to label the whole thing all the way around. Here's where that is. Okay, so if you do want to memorize it, there it is in the yellow highlight in the 4th quadrant, and then there's the terminal point. Okay, the way I want to break it down though, again, trying to maybe not memorize the whole thing, I'm just going to say, well, I know that because there's a 6 in the denominator, 6 in the denominator means I'm closer to the x-axis than I am for any other point. So it's one of those 4. Again, let me mark at least this one. There's our quadrant 1 that's referenced to the side to the right. So there's our pi 6th. Okay, and then I know that all of these also have a 6 in the denominator. And then all I have to do is just figure out, well, where's the 11 gonna put us? Well, 11 over 6 is very close to 2. So I know that's the one that's closest to 2 pi. Okay, so we went almost all the way around. There it is. to 11 pi over 6. So that green arch is the 11 pi over 6 length around the unit circle. Okay, but it did say find the terminal point. Well, again, if it has a 6 in the denominator, I know it's always going to look something like this, but I just need to make sure my signs are correct. I'm in quadrant 4. That must mean the y-coordinate is negative. The x-coordinate stays positive. So that is the terminal point. Okay, so let's try number 2. So number 2, I'm still going to draw my unit circle. So something big enough. And then I'm thinking, again, it has a 6 in the denominator. So kind of like the last time, I could still say, well, it's got to be one of these 4 that are closest to the x-axis. That's how the 6 in the denominator pattern works. This time around, though, it's negative. Well, again, my first quadrant, there's where pi 6 would have been as a positive. Again, the negative just tells you go the opposite direction, go clockwise. Okay, so let's mark that one in red this time. So right here, and we'll just make it even bigger. There we go. That is our negative pi 6 length. So we're in quadrant 4. So it's the same answer as our first one. So that can happen, that's okay. So it's square root of 3 over 2 and negative 1/2. So that is the terminal point for this question. Okay, and then number 3, so I drew that big old reference to the side, again, kind of just focusing on the denominators that are in the t value. To do this one, t equals negative 2 pi thirds. Okay, so I should have maybe written that somewhere else. I'm going to put it right here. So number 3 is there. Okay, so again, I'm focusing on the 3 in the denominator. So 3 in the denominator, instantly I know is always one of the 4 that's close to the y-axis. And those are our pink highlighted ones here in the main unit circle. Okay, and I have my reference right down below this, and we could even mark it for now and say, well, there's where pi thirds is. I need to figure out where negative 2 pi thirds is. Okay, so negative 2 pi thirds, that does tell me to go clockwise. Well, I can kind of use the pattern that we did from number 2. We know that this length right here would have been negative pi thirds, because it's the same length as the positive, just going in the opposite direction. And then after that, I'm focusing on the 2 over the 3. So 2/3 is smaller than pi, so it's still going clockwise. Over to the left side would be negative pi. 2/3 wouldn't get all the way there. It has to be this one. Here's where negative 2 pi thirds would be as our t value. And let me mark that in red also for this problem. That right there is the negative 2 pi thirds t value. Okay, and so now again, I'm in quadrant 3. That means both the x-coordinate and y-coordinate must be negative. And I'm going to kind of just squeeze it right next to it in the red. Because it has a 3 in the denominator, it matches the same numerical parts as the first quadrant. But again, I'm in quadrant 3, so I need to instantly make these negative. So this right here is the terminal point for our third problem where t is negative 2 pi thirds. Okay, so that's it. That's just a couple of them. Okay, so try to get those patterns, memorize this, do whatever it takes. And I kind of scrolled already. It's something that we use throughout the whole course. This is just part of the course, this whole thing of paper. Okay, so it really is involved in everything. So if you know this well, you'll do well. If you don't know it well, you won't do well. All right, so try your best on it. Okay, anyway, that's it for now. Thanks for watching. If you do have any questions, please let me know.